to see about this particular interface, which is you can see from here in this board, that is the Adams View software. So first of all, how to download the student edition, which is readily available. So first of all, you can go to the Google and simply write MSc Adams View student edition. Okay. So once you will go here, you will first find out this student edition, and you can see here student edition download now. Okay. So once you will carry on, so here it will ask some username, password or registration. Okay. Suppose you don't have any account, so simply you can register using this register option. Suppose I am going to register it. Okay. So this information is required. What is your name, last name, your email ID, which affiliation means what is your university name, and graduation year. Even if you are working somewhere, you can also download it. Means you can apply for the student edition. There is no problem. Okay. So you can simply put your you can say the ID card when it is required. Some upload your student ID. It is there. Na? So simply you can put your ID card and then you will register. So within 2 days, it will show like 7 days. After 7 days, you will get the mail. But within 2 or 3 days, you will get the mail that your student edition is ready and you can download it. So that is valid for 2 years. Okay. So it is very good software. Now once you will see that one, suppose you have login now. Okay. So you will find out a many software which is like this. Okay. You can see a lot of softwares are available. Okay. So here many softwares are there, many applications. Okay. So here you can see Adams View software is there, MSc Adams Student Edition, that you can download. Okay, it is around 2.5 GB, not more than that. Okay, so it will work fine, and also it is the latest version 2024. So each year the latest version it will come. So once you will download it and then run that particular exe file, then you will find out your software will be installed. There is no need like you have to give some other information in between the installation. Many softwares require yes or no and other things. Simply you click it, agree, and then everything will be downloaded. Okay. So once you will download it, so you will get some interface. What kind of interface you will find out? So in your desktop you will get like this particular interface, Adams View Student Edition. Once you will double click it, you will find out this particular interface. Okay. So here it is asking, or it is showing that what you want to open, a new model or existing model. Okay. Or you want to exit. Okay. So suppose you are first timer. Okay. So you don't know anything about it, you want to learn about it. So simply you can go and see the new model. Okay. So now here the thing is that you have to give some name. So you remember the alphabet and the numeric value or any special case number cannot be directly entered together. You have to make a like a under dash kind of thing. Okay, then it will work. Okay. So suppose you want to give like a test 1. We are going to make a test one particular part. Test 1. Okay. So now gravity it is asking. Yes, I will give the gravity. Okay. Unit, what kind of unit you want to give? So here that CGS is there, MKS is there, MMKS is there. So we simply you use like a millimeter for the displacement, weight for the kg, load for the Newton, and time for the second, and angle for the degree. Okay. So this particular MMKS is okay, so you can choose this one. Now the working directory, suppose you want to make some working directory in your desktop, so you can write it Adams directory. Okay, dir. Okay. So now you can simply browse this one in your desktop and choose this one. So whatever you will work, okay, everything will be saved here, and then close and done. So now you see here, you will get a square kind of some hat, okay, or some triangle type of thing. So it looks like always it would be there. The shadow always would be there because it is the student edition, it is not a licensed version. Okay, so you can simply work on it. Now, why we are using this software? That is the most important part. This was the other things which we have seen, that is the introduction. Now why we are using this one? So the main aim of the using is like a design, okay, and simulation and control. These three part you can do it. Like suppose you want to design a arm, like a 2 degree of freedom arm, okay, or a parallel manipulator, or any kind of mechanism if you want to design, that can be done using this software. Okay, even you can design in some solid modeling software like SolidWorks, AutoCAD, CATIA. You can design it and you can import here. So the things will be imported here, and then you can define its because we are working in the robotics or mechanism. Okay, so the robotics and mechanism, what is it is related simply the link and joint. Okay, so link and joint combination is there, means it is the robotics. Okay, so joint means there are certain joints are there, like a revolute joint, prismatic joint, spherical joint, okay, cylindrical joint. So this joint have some constant and some motions. Okay, so in the robotics we have to provide some robotic structure which is having this kind of link and joints, and according to its end effector perform some work. Yes, so this is the way we are going to see here how to design. So suppose this is my structure, so you see here lots of things are there, so we simply cover within a 1 hour we can directly design a model and see the using of those particular which kind of tools we can use to model it, so you can understand better rather than I will show you this is for that, this is for that. It will not work. Okay, better we can design a model and then you will find out yes it is okay. Okay, so first of all, this grid size, or is it visible to you or not? Visible? Okay, just a minute, or I can change the color. This is visible now. Okay, so this particular the bottom side, if you right click and change the different color, blue color, black color, gray color. Okay, so like that. Okay, so suppose I will choose the white color, that would be better for more visibility. Okay, so now here the grids are there, it is by default grids. Suppose you want to make a bigger size robot, so you need to have the bigger grid, okay, or bigger dimension. So for that what you will do, you can simply go in the settings. Okay, and in the settings you can see many things are there. So our first time is here working grid, so I will let you know about the working grid. Okay, so by default how much it is? 750 millimeter is the x direction length, and y direction 500 millimeter. So if you want you can change it. Suppose we want to change it 1000 millimeter, means 1 meter by 1 meter. Okay, so that would be the good one, 1 meter. So 1 meter by 1 meter, and each grid have a means each dot is having the 50 millimeter space. Okay, so I will make it like this. So now it is okay. So now here you see this is a this particular lens is like a dynamic zoom, means if you will click it and you will place your mouse like this, it will be zoom in, and if you make it like this, then it is zoom out. So I will do like this only. I will press the left click and press like this. So it is, I am just moving my side and moving your side means zooming. Okay, so like that it can be done. Okay, so now the other one is now we have the grid size, we have the unit. Now we can design our system. So what design you want? Suppose any robotic mechanism, you let me know, robotic system or mechanism, within 1 hour we can explore. So you let me know what kind of design you want.
Pick and place.
Pick and place robot. Okay, so in the pick and place robot, one part is like a rotation and there is a two arm. Okay, so one arm, one would be like a, it will be rotate like this, the base, and it is having the two arm like this. So one it will rotate and pick and then rotate and place. Okay, so that we can make it. How we will see now. So now here we will go here. So what is the first requirement? This cylinder is required, a rotary bar is required, or one link is required which can rotate. Okay, so for that we can find out a cylinder. So where we can create a cylinder? So here you can see the bodies. This is the bodies. These all are your bodies. Okay, so now here what are the bodies? Box, cylinder, sphere, and frustum, and these tours and the links and the plate. So our first requirement is cylinder. So I will click on the cylinder. Okay, simply clicked it, and in the right side you can see left side what is the thing is reflecting? New part. Okay, so or if you will cursor it to ground or on ground. Okay, so suppose I will say the on ground, it is connected to the ground. Okay, so now what is your length? If you will not choose the length and the radius, now you see here, if I am not choosing it and I will click somewhere here, so you can say the radius and length is changing automatically. Okay, there is no uniformity. But if I will choose the length, suppose 50 centimeter. Okay, and the radius suppose 2 centimeter, and I will click here. So now it will create it. Okay, and I will again click. So it is the wireframe structure. So now it is the wireframe. You can see it's the wireframe. So this one is for the rotation. This symbol is for the rotation. Once you click it and move your mouse, your system will rotate. Okay, and this is for the zoom fit. Okay, and this particular is the front view, right view, top view, like that. Okay, so now so our cylinder is ready. Okay, now what are the other things are required? Two arm. Yes, so two arm we can make. One arm would be here and another arm with the other arm. So like two links. Okay, so suppose this is my link. This one is your link option. Okay, so I will choose this link again. I will choose, then it will say new part. So now we are adding with the part. So the new part, it is okay. Okay, now the length is required. How much? So length I will choose, suppose 10 centimeter. 10 centimeter first link length. Width is suppose 2 centimeter. Okay, and depth suppose 1 centimeter, means thickness. Okay, and I will simply choose this part because here we are going to edit. Okay, so now it will show the which direction you want. Here, 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 like you can rotate anywhere. So the length is very small, so we can make it somewhat large. Okay, so we are escaping it, and again we will go here and we'll make like a 50 centimeter suppose. Okay, and I will choose. Okay, now it is looks somewhat okay, or it is also bigger. So suppose this is 25. It will be okay. Yes, now it is okay. Okay, like this. Okay. Second, also again I will choose second arm. Yes. So this is basically my structure. Okay, and you can see the cylinder height is somewhat bigger, so we can make it reduce. So what I will do, I will click on this one and click on the right click, and I will go to the part and modify. Okay, in this modification, no, it is not happening here. So I will go here, cylinder. Okay, cylinder, you will go cylinder and then modified. Yes. Okay, so now you will go and you change the length. So suppose my length is 50 here, so I will write here 25. let's say. Okay. So now the connection is not done. So again I have to make a, means I made it from here. Okay. So now the connection, how, so this is 3 different parts we have. Okay. But we have not given any connection. This 3 structure we have drawn only. Okay. Now we want some connection. So what are the different connection? So cylinder is there. Cylinder can rotate about which axis here? What are the axes there? X axis, Z axis and Y axis. So Y axis, rotation about Y axis. So that rotation must be done. Second, the first part is going to be connected with the cylinder end. Yes. So that connection will also have revolute joint. Okay. And the second part is connected to the third part, that is also having the revolute joint. So this 3 connection is required. So now the after body there is a connector. You click on the connector, so you will find out the what are the different connections are required. Okay. So what are the different connection? Like a fixed connection. Suppose this cylinder is required with the ground as a fixed or rotary. Rotary required. So fixed is not required. Okay. So the second connection is, you can just click here. A click means you just put it here, so it will show like a create a revolute joint. Yes. So it is the revolute joint, means a rotary joint. So that is needed here. So I will take this one like a this. Okay. Now it is showing that you have to choose the connection between 2 bodies and choose the location where the rotation can initiate. Okay. This is first option. Second option is the one location body implied, means already body is defined. So choose one location which can be rotate. Third is 2 body, 2 locations. Okay. So generally we use 2 bodies, 1 location. Okay. Now it will show the peak to grid or geometry feature frame, peak geometry feature frame. Okay. So generally we use the normal to grid. Grid से normally बनाओ. ये grid है. There is a grid, and the grid to normal means towards the which direction? Z direction. Yes. So this is the second one. Now choose the peak body 1 and second body. Okay. So now what I will do? I will go here and choose the peak body body 1 like this one. Okay. And second body this one. Now I will choose the location. So these 2 locations are far away. So first of all, we have to first combine, or it will be taken care from moving from that position to the cylinder joint end point. Okay. So what then how I will do it? I will simply first use the movement of this particular part to here. Okay. So for that I will here this particular option is there, which can, if you will right click it, there is a lot of many options. Okay. So first option is rotation, position, orientation. Okay. Second one is the movement. So this option we can use it here. So simply I will click here. So again it will saying that from to or vector. Okay. From to means you choose one point and pull it wherever you want. Okay. And vector means once you choose, then you define from x how much, from y how much. Okay. So therefore we can use the form from, and I will choose this first one, this one. Okay. And I will choose this to here. Okay. So it is transferred. Yes. So this is the, now you can see here whether it is transferred. Okay. So this is the first point. Again this third point we have to connect with the second point. Again move option we can use from this point, this part to this part. Now it is done. Okay. So now basically we have our different, you can say, one system. Now you can make it a solid body, so it will be created like a solid body. This yellow color solid body is this one. You will click it, it will make a frame or solid. Okay. So now it is converted as a solid body. Okay. Now after that what you will do, you have to define the joints. So as I told you, first we have the revolute joint. So this one we rotated about the ground. So part 2 and part and the ground. We will choose the ground. So we can just click somewhere here, and where the rotation happen, this one. So we are clicking like this. Okay. Now you see this rotation is about Z axis or Y axis. Huh? This rotation, it is visible now. कौन सा है ये इस reference में, this in this reference it is about Z axis, but we need a Y axis because the Y axis rotation is required. So simply we can go here, click right click and see if there is a joint is reflecting or not. So yes, right click, yeah. Now you see here some joints are, is there any joints? No. Again you click here and then yeah, now a joint 1 is visible. So you go here joint 1 and then modify. Okay. Then here you see what are the modification. This is the second modification which is called as the change position. So I will click it here. Now this option will come. Okay. In this option rotation. So rotate your axis till the, it will convert it as a Y. So suppose if it is like this. So if I will rotate, so how much angle it is required to rotate? 90 degree. Yes. Okay. So I will choose this one 90 degree increment. Okay. And about which axis? Y axis. We need about Y axis, na? So that's why we have chosen it now. Okay. Okay. And if you want, you can check it to rotate it and check. You can zoom it and check whether it is done or not. So you see here the rotation is where? Still it is not done. It is like this. Okay. So again we have to choose this joint, modify and Z. Yes. Yes. Now you see the Z axis rotation means it will rotate about uniformly. It is Y axis rotation, but itself about its own frame it is the Z axis rotation. Okay. So now we can make it a simply frame like this and like this. Okay. So first joint is defined. Now the second part and third part is having the first part and second part is having the again revolute joint, but this revolute is about Z axis. Okay. So now we can see here again we will choose here, we will choose this part and part 3, and this is the location where the revolute joint is needed, and click. So this rotation is correct, the direction is correct, so no need to change. Okay. And another one is this 2 point. So again we will go here, part 3, part 4, and this is the location. Done. Yes. So now we have our defined all the body and joint, link and joint is defined. Yes. Now we want to give some operation, then only we can check whether our simulation or things are working or not. Okay. So how we can do that one? We can give some 2 ways we can do, either forward kinematics or inverse kinematics. So I think you all are aware about now what is forward kinematics, what is inverse kinematics. So forward kinematics means we have to give some joint information and needed the end effector positions and orientation. Okay. Similarly in the inverse kinematics, we need to give some information to our robot in the form of the Cartesian coordinate or end effector position, and we are looking for what is the joint joint angle or joint translation, this kind of information, or joint displacement. Okay. So these two are correlated to each other. Okay. So suppose here I want a forward means I want to give some information to the end effector, and I want to see whether my joints have performed that properly or not. Okay. So generally this kind of analysis is like to decide what kind of actuator you need, like a motor actuator, translation actuator. Okay. So to define your end effector job, you have to find out this is my requirement. Okay. So for this requirement, this is the obvious practical part, na? Suppose you want to need something in a market. Okay. Or you suppose you want to go to some destination Goa. So to go Goa, to define the destination Goa, you need to come back like from where to where we have to go. Okay, what kind of tickets is required, trains जाएंगे, bus से जाएंगे, flights जाएंगे. Okay, so these are all connecting information you have to find out. Okay, or you have to decide it. Okay, so that's why if we will give some information in the end effector, means we are looking for the jointing or joint or connecting information. Okay, so that's why we are giving here some information. Suppose this one is my end effector. So this end effector I want to give some motion. Okay, so I say there is a two type of motion you can give. Either you can give the joint motion, you can find out your end effector positions and orientation. Similarly, if you will give your position and orientation, okay, end effector, so you can give the joint information. Okay, so here we are going to give the end effector information. Okay, we are putting here some desired point. Okay, and we are looking to see, we are going to see what are the performance done by my joints. Okay, so here you can see the third one is the motion. We have to give some motion and look for it. Okay, so suppose here these are the joint motions. Okay, and these are the end effector motion, that is called as the journal motion. So first one is related to the point motion, 1 point to 2 point. Okay, and third one is the second one is the generalized general motion point motions, means you will give all 6 degree or 6 motion to it, and it will define which one is free, which one is not free. Okay, so okay, so two body, one location. Okay, suppose this is my body, part 4. Or you can choose a simple one location. Just I'm getting some call. Hello. Sir, class में we can simply give the one body, one location, one body. So this is my location where I need the motion. So once I will click, you can see motion 1 is the name of it. Okay, and different, what are the different possibilities? Translation about x-axis, translation y, translation z, rotation about x-axis, rotation about y-axis, rotation about z. Okay, so it depends on you which one you want to make a free, and which we want free means which we want you want to make some constraint. Okay, so our motion is, what is our motion requirement here? क्या है requirement here? So it can rotate about which direction? Huh? Rotate about y. Okay, so this will be a some displacement is there. Okay, and also it can stretch like this. So which direction it is? ये कौन सा x direction? वही है ना? वो ये जो है this one will straight, तो ये जो नीचे वाला है this one, this axis is equal and this axis. So x axis, okay, or also the z axis, it will come like this side. So this particular plane is xz plane. So this two also information is required. So suppose we will give only for x, suppose right now, okay. Now others will make the free. Now we will give like a translation about translation. It's a rotation, ना? Translation तो कौन सा होगा? Rotation about y-axis. Yes, and translation about x-axis. Yes. So now rotation about y-axis. Suppose I will give some rotation. This all will be in the degree, as we have mentioned, degree into time. Okay. So suppose I will give like 40 degree, 50 degree. Suppose I will give here some with respect to time, displacement time. Okay. So here I will give just a minute for checking purpose 0.1 into time. Okay. And displacement here 10 into time, suppose. Okay, let it be like this only. So now I have defined something. It is constrained, means these two motions would be possible. Okay, so now we can see the simulation. So here you will come here directly to the simulation part after that. Okay, so in the simulation you can go here, and this is the simulation. Run the interactive simulation. So once you click it, you will get this box. In this box you can define the end time or duration, at what much time it should run. Okay, so suppose I will define time like a 10 second. Okay, 10 second is my time. Step size, suppose each step is a 0.1 second. Okay, now if I will click this one, so it will play. If there is some error, it will show some error. Another, yeah, you see here. Okay, so why it is having some error? Because after singularity, as you seen, professor discussed now, there is some singularity. Okay, so after singularity point, it is not able to rotate further or move further. So that singularity point is existing here. Okay, so that is why. So better we can also make it as a 0.00, so we can see the very small, you can say the simulation. You see. Yes. So this is now like this only. This side it will fluctuate. Okay, because we have given some like a motion. This motion we have given. Because of that it is happening. Okay. We can change the motion like a z direction also. So suppose translation about z direction. So 10 times. Suppose, let's see what will happen here now. So it will not run, means it is saying that either you can give this direction or either you can rotate in this direction give. Okay. So this will not work. So it will make it free. Suppose you can give in the form of sine, rotation in the form of sine into, if there is some error, it will always show yellow. Sine, okay, sine theta. So how can we write sine theta? How can we write sine? So time is always there. Sine. Suppose sine time I am writing. There is no error. Okay. So now the frequency. Okay. 2 into frequency. So this E is the problem. Okay. Sine means we can write SIN only, not E. Okay, sine 2 times t. So now the displacement is sine 2 times t, it means rotation, with some 10 degree. Okay, again there is a error, means singularity is finding. So we can change it like that again and again, and we'll see in which point it is going. Okay, so you got it. This information we have to give to the end effector, and then we have to run our system. And now we ran it. Okay, all the system is ran. So now after that we want to visualize our result, how much it is done, means our joint performance, joint angle, joint velocity, to perform the end effector task. So we have given some end effector task. Now what are the joint performance done to perform this particular end effector task? So simply we can go here and click on the joint. So this joint is there. Okay, so make it large so we can catch the joint. You see joint 3. Okay, so in joint 3 you can go and you can find the measure. Measure means measurement of different parameters. So now you can see the different parameters will come, like joint is there, component. If you want to force, torque, velocity, displacement. Suppose we are displacement, we are going to means what are the displacement, what is the rotation angle is happened. Okay, so that displacement we want. So we can give the magnitude and we can apply. So we can see what is happened to this particular. Not much movement is happening. Okay. Similarly, if you will see in the Z direction, is there any movement? Not much. In Y direction, not much. In X direction, not much. Okay, so this doesn't have the much information about this joint. So now if you will go for this joint, again here you can connect and find out joint 2, then measure, see the displacement of the magnitude. So again here, okay, so joint itself doesn't have the information. Okay, so now how can we get to know, because there is some rotation is happening. Okay, so that rotation, to detect that rotation we have to define the measurement of the angles between the two links, because joint is the rotating but it is a slight rotation and it is moving higher. Okay, so that's why we can use the measurement. So for the measurement, what will go, we can go to the design exploration. Okay, in the design exploration we can see here, this is the measurement part. Okay, so here we want to measure the angle. So what is the first one? Create a new measure. This is the create a new angle measure. So this angle we can measure it. Okay, and this is also the point to point measure. So here we can click this angle measurement, and we want to make an angle between this part 2 and this part, means from here to here, here to here, like that. Okay, so now we have some angle measurement of the system. So different measurement you can provide it and find out. Okay, so this is the one kind of job you can do to find out the relative motions of the between the two parts. Okay, now let's see one more example, and with that example what we will do, we can find out we can say the complete picture of the post processing. Okay, so let's see second example. So we can save this one as a one example to understanding the system. This is the understanding of the system. Now file, new database, yes. Okay, yes, now it will be new database. Okay, so now the new model is the test 2. Test 2. So the same C is coming, so again and again we have to give the directory. Okay, okay, so now we have, so you can check earlier case is there or not in your folder. So now earlier case is there, test 1. Okay, so now this is the test 2. Now suppose, okay, yes, so again setting, you can go and decide your working rate, which is by default this one, because you need the higher. Okay, okay. Now suppose we want to make a mechanism, like a simple mechanism, and do the analysis like a slide diagram mechanism, okay, and see what will happen, what are the things we are getting. Okay, so suppose for that the same thing, a link we have to decide. So this is the length, length we can just leave it, width we can just make it like a 2, depth we can make like a 1. Okay, so 1. Now from this origin point we can choose some length. Okay, suppose this is my length. Yeah. Okay. Similarly, one more we can take it here and we can give somewhere here, because we want a one slider also. Okay. So this is my second point. Now for the slider I have to create the box. Yes, so I will just choose this box and I will choose the height like 5 centimeter or 8 centimeter, and depth is also 8 centimeter suppose. Okay, and I will free to choose the length. So this is my box. Now I want to see whether it looks like how it look like, so you will see. Okay, now I want to move from this position to the connecting of the last point. Okay, so that I can do it here using this option, movement from this center to here, it is moved. Okay, so now we can see like this. Okay, so now it is a slide diagram mechanism. To make it slide diagram mechanism, again we have to give the joints. So we can go to the connector, we can give the revolute joint, ground to this point part 2, and this is the location. Okay, and then again this part 2, part 3, and give the location. Okay, third one again this part, ground it is choose. So part 3, part 4, and this is the location. Okay, so these are the rotary joint, but one is the translation, the end effector with respect to ground. So we can go and here the other part is the translation. So we will choose this part 4 and this is the ground, and this position or this position we can choose as a translation. So this position I am choosing, and it will ask which direction translation, this direction, this direction, this direction, or this direction, which direction. So suppose we are choosing this particular direction. Okay, so now everything is done here. Okay, so now you can give, now we will give joint rotation, joint motion. Last time we have seen the end effector motion. Now here we will give the joint motion and we will see what is our values. Okay, so motion I will give the joint motion, like this is the rotary motion and this is the translation motion. Okay, so suppose I want to see the, I want to give some translation motion. Okay, and I want to measure the input of the rotation, means for this much translation how much the rotation have done on my motor. Okay, so suppose I will give the translation and simply I choose this particular joint, joint 4, which is the translation joint. Okay, so now here the one motion is created, that is the translation motion. So I will, if I will click here, motion 1 is there. If I want to modify it, you can modify it, and you see the translation motion is the 10 into times of the function. Okay, suppose I want to run it and see what is happening. Okay, so again here in time is 10 seconds. Okay, step size I will give 0.01. So a small step you can see. Now I will see there is something happening. not looking, so better we can give some more like this. Yeah, some motion is happen. Okay, so basically I will give like this. I want to see. Okay, so I don't know why this part is there. So yes, so I will make it a white background. Okay, so now I will give like this. Okay, suppose I want to change in the sinusoidal function. Okay, so sine 10 times into sine into 0 point frequency. Okay, and time. Now I'll apply this one. Oh, now I will run. Okay, so I will give much. 10 times means 100, suppose. Okay, so I will give the maximum time like a 100 seconds. Okay, so this is the information we are getting here. Now what is happened to my joints, again I want to see, so we can connect here, give the joint and see the measure in the magnitude part. So now you see the joint information is coming like here, some angular position. Okay, so if I will run again, now you see it with running it again like this. Okay, so this is the rotation which is happening in the joint. Accordingly, you can specify or a specification you can give for your joint. Okay, so this is a very good software for doing this kind of job. Now you want to track the motion, or as per the conditions we have to design some planar manipulator, as our whole lecture is on the parallel kinematic machine. Okay, so let's design one parallel manipulator and see the behavior of the planar manipulator, like a XY theta manipulator if you want to design. Okay, a simple manipulator. So let's see like a XY theta motion stage. Okay, and based on that we can find out how the analysis may be done, like a tracking position. Okay, that can be done. So this is the test 2. Now again we will go and find out the new database and test 3. So today I am doing like a for only kinematic part. Okay, so dynamic part we will see in the next classes, like the same. So if you find some software, this software, then you can download it till tomorrow. Okay, so okay, again, so again we can just make it white background. Okay, and now we can draw some manipulator which is the XY theta. Okay, so which kind of mechanism we can make, like suppose we have this simple stage. I will just make like width, because these things are very important. So this 2 and this 1, choose the length as per, or we can choose it like, okay, as per our requirement. So like this. Okay, so I am just making one platform. Second one is from here to here. Okay. Third one is from here to here. Okay, now the box, 3 box I will, so it can translate. So I will make the 3 box, so height and depth, so I will make it 5 5, and I will see. Okay. Yes, in one box. So we need 3 box, 3 box, 2 box. Oh. Okay, so now I will move this box to the middle of each leg. Okay, so let's see the movement. We can do it using the same theory. This one to this one to this one to this. Okay, now again one we can say link we can create to make a connection between passive translation joint. So what I am making, I will tell you. First let me make this one. So again I will create this part 2, part 3 cm. Oh. So now this part 2, this part. Now this is required some rotation, so I will delete it because this is not required in this present form. So I will make it like a vertical. Okay. So now I will choose this one to here. Got it? Now I will make a plate to connect these 3. So this is the plate. So this one, this one, this one, and this one. So right click. So it can be a plate. So like this is my one system. Now I will let you know in the board what I am making in the planar parallel manipulator. Okay. So So here we are going to make planar parallel manipulator. So here you can see it is a structure of like this one. There is one translation, second translation, third translation, and then another translation, another translation, another translation. So it is connected with the end effector. Okay. So here what is there? So this can translate and this can also translate. So this translation is the powered one. Means you can give some power here and it translate. Here also it can translate, and this part is also translate. So it is also powered one. This one is a powered one. So this is also active one. This is the active one, and this is the passive one. So this is the powered one translation of this one is the powered translation. This is the powered translation. So this is the passive translation. Okay. So this is the passive one. Okay. T passive. Okay. And this is also T passive. Okay. And here we can make some revolute joint. Okay. So it can be each leg having the prismatic and revolution. Okay. So using this particular system, we are getting the X and Y translation. X motion, Y motion, and because the difference of these two, we will get the rotation about Z axis. Okay, so that is called as the XY theta mechanism. So this part, I think time is up. This part we will see in the next class, how to design this one and complete modeling of this one. Okay. So thank you very much for that. If you have any query, you can ask.